Welcome to Python tutorial on lesson number 3. This is a continuation from the first part of the lesson, which covered strings and lists, and now we'll be talking about dictionaries. So we're going to do that. We're going to be launching the binder. You can follow the link in the description below for the video, or navigate to our BVCN GitHub repo. So to start this up, we're going to click on the tutorial 3 IPython notebook. You can continue if you are coming in from the first part of the lesson. There's a lesson 3.1 that covers lists and strings, instructed by Ashley Cohen, which is available and linked below. This is the second part of the lesson, which we will continue from this part of it, starting at dictionaries. So dictionaries are one of the data types that fall under the immutable category, and really, for me, make one of the most useful types of data packaging that Python offers. And it's one of those types of data where it functions in a way that you might not be used to when you first start with it, and can be difficult to kind of understand how it's organizing elements to it. But as you progress with it, it's one of the data types that has the most strength, as there is lots of elements that allow it to be built into situations where instances where lists would function. So an example would be where you have a really long list. Really long lists consume a lot of memory every time that they get looked into, because every time you look at a list, you have to read it into memory and then run through it, whatever you're trying to do. Dictionaries work differently because they allow you to store all your data in active memory. So searches happen at a much faster rate, especially for large data sets. And so there's this element to a dictionary that just seems kind of bizarre at first, and then starts to make sense, and then becomes what honestly is now my favorite type of data type in Python to work with. And so the key about dictionaries is that they come in a fixed format that's a key value pair. So similar to an XY coordinate on a graph, what you end up with is a key that links directly to a value. And so a couple of examples would be food types of cities. Chicago is associated with deep dish pizza. That's the link, the key, and the pair. New York is related to thin crust pizza. That New York is the key, thin crust is the value. And so we can use the parameter and data values that were presented above to have a look at this and look at how we can convert our lists from two separate entities into one combined entity that contains all the same information. And so the way we can do that is there's a couple of ways we can take this information and convert it. The first is we call an empty dictionary, which we do like this. We're using the variable name dict1, calling an empty variable. So unlike lists, which use square brackets, we use curly braces here to denote a dictionary. And then here I've just typed in the values one at a time. And so you'll notice a couple of elements about this that I want to point out is that each pair is denoted by a colon in between each element, and that for strings you need to denote that it's a string like you would anywhere else in Python. In this case, I'm using double quotes. You can use single quotes. And then there's a colon value, and here we have a float numeric value. And so we can store that information like this. The other way that we can do it, and it was demonstrated towards the end of Ashley's demonstration for demonstration 3.1, is that we can take a list of tuples, right? So something that we've already ordered, where we're same format, but now that we've paired our data with this comma format, and we can convert this existing list, right? Notice the square braces, and then convert it using our dict function to go from a list to a dictionary. And so we can run all of this code like this to make sure we populate it all. And then when we get here, what we do is we generate two examples of the dictionary as is, right? So dictionary 1, which we wrote out each of the elements for, and then dictionary 2, which has the same information, but we converted it from a list as we go. And so one of the things that's interesting about a dictionary is that unlike lists, they're not indexed. And so while it looks like what we've done here is that it's in an order, right? Sample 1, sample 2, nitrogen 1, nitrogen 2. When we look at the dictionary, in its format, we have its pairings of the string that it's paired with and its value separated by the colon. And it looks like there is a organized element to this. But really what's happening is the dictionary is preserving what we gave it to begin with. And so when we get to the point where we start wanting to call up individual elements from a dictionary, we run into something, and this is part of the reason why dictionaries can be difficult to understand, is that strings and lists function exactly the same way. Strings are treated as lists of characters, and lists have all these information about the indexing. Everything's important. Where it is in the list is an important value on that. And dictionaries just don't function like that. And so if we try and call dictionary the first index value like this, what's going to happen is we're going to get an error. And that's because what we've done is tried to say, hey, give me back a value, or a key in this situation, a key called the number 1, and give me back that. And our dictionary doesn't currently contain that, right? So there's no information about position or elements like that that are kept for a dictionary. So what we do to get this is that we use this formatting. So we have dictionary here, and then what we use is the square brackets to denote what we're looking for in terms of the key. And then we give the dictionary our key value. So in this particular instance, we have sample 1, which up here, sample 1 corresponds to the value 0.4. And so now when we run this, instead of trying to force the dictionary to look for a value or a key called 1, or to ask it for something like in the first position, give me that, what we're saying is look for the key called sample 1 and then give me back the value that's associated with that. And so we can run that, and we get our 0.4 back. And so it's important that we can figure out how to work with some of this information about how to modify and work with dictionaries going forward. And so there are a couple elements that we can do. We can add elements to a dictionary by defining a new key and a new value to go along with it. So in this case, we're adding sample number 3, which has the value 4.1. And so all we've done here is the same setup, but instead of a key value that's already present in the dictionary, we're providing a new one. And so when we run that, our dictionary has now added, again, in the order that it was added, sample 3, 4.1. But again, this order is not being indexed in any capacity. So we can modify it. And so the way we do this is we take our target key name and then just set the value to something different. So right now we can reset it to 3.7 if we run it like this. But we can also do things like set it to something different. So I can take this information and we can set it to a different value. We can set it to 1. And so I'm going to just cover this up. And so we'll see that this changes. So now we can set it to 1. We'll talk about this more in a second, but we can set it to a different type of content. So we can set a string here. We can call this sample 1 and then nitrogen 3, which would be obviously not ideal if this is how we're trying to organize our data in pairs. But we can make that change. And all we're doing is we're saying, if there's this key value, change what it is based off of what we're giving it at the equal sign. So to give you an example of what would happen, I'm not gonna do that. We're gonna have to edit that out. And then lastly, what we can do is we can use this function called delete. So in this format, we use the letters D-E-L. You can see those in green. Dictionary, and then the key that we want. And this will then also drop the whole key value pair. And so you can see that it's now no longer part of our dictionary. And so this is where I want to get into. So I switched what we were working with in our value for that sample 3 in dictionary 1 from a float numerical value to a string type. And so there are a couple rules that we have to follow going forward with dictionaries. And the first one is that keys have to be immutable data types. And so these include string, integers, float, and even booleans. And so this is a fixed thing that has to happen, right? You can only use one of these 4 data types as the key value for your string. And this means that it excludes any of the mutable data types, so tuples, lists, and dictionaries. You can't have a pair value as your key. You can't have a whole list as your key. You can't have a dictionary as your key. On the flip side, your values, so the elements that are related to your keys, can be anything. They can be objects, you can call functions, they can be more dictionaries. And so that's one of the things that can, one, be complicated, but two, very useful, is that you can use dictionaries to house further dictionaries, which can then house dictionaries, which then can house a list, which then can have your values. And you can organize your data in this way so that you can step down through whatever hierarchical structure you have to get to the value that you want. So let's explore a little bit about what's going to happen here. So here I have a new dictionary that I'm calling Dictionary 3. And I'm going to create it in a couple of different ways, right? So I'm going to say Dictionary 3, we're going to create it, it's going to be empty. Here's a key, and here's its corresponding value. Here's its key and its corresponding value. And then here, I've changed it. Instead of being a string as our key value, we're going to use a numerical value. So here I'm going to use the integer 0, and then the integer 13, and then set the value that it's being stored in as time and date. And so when I run this, we'll get back a dictionary file data type that's broken up like this. And then you can see here, the key value is in fact the number 0, along with the value time, and then the key value here is 13. So let's explore what this would do. Right, so here we can take our phosphorus 1, which is currently set at 0.5. We can reset it to 1, and then here it looks like I'm asking for what would be the first position in the list. And instead of getting back, sample 3.1, what I'm getting back is the key value zeros values pair. Right, so I put dic 3 and I get back time. Right, so even though I set phosphorus to 1, right, I gave it a value that it works with, even though it looks like sample 1 is the first element that I want to work with here based off of just what the order looks like on the screen. In fact, what I'm doing is I'm asking for this key, right? It's because 0 is the key. So if I tried that example from above, where we use 1 as the key value, we'll get, again, an error for this because 1 is not a key in our dictionary, and our dictionary values aren't indexed in any way, so there's nothing to call from 1. Unlike 13, which is a key value, and now we can generate the value that's linked to that key 13. Okay, so here's an example of a dictionary within a dictionary, and so I've just set this up using the format that we've had already, which is these 4 parameters from sample 1 and sample 2 and their corresponding made up nitrogen values. And then here we've broken it down as to the names of 2 organisms. So one is bacillus and one is roseburia. So the only difference is that we have a key here called bacillus, a key here called roseburia, and then that key is now linked to a value that is another dictionary. So in that dictionary, we have more values that are related to that. And so when we print this, what's going to happen is that, let me run it, comment this out and run it first. So what's going to happen is that we're going to generate the output of 2 dictionaries that come from both of these names that we've listed, right? So the first key that we're looking for is bacillus, and so that returns in this print statement a dictionary that has the bacillus values, which are here. And then the second one is we want the dictionary associated, or the value associated with the key roseburia, which happens to be a dictionary and is output as a dictionary. And so if we wanted to get to the values that are in the dictionary, we use a very similar format as before, where we're using the square brackets to denote the key that we're looking for. And then because it's just a dictionary within a dictionary, so first what we do is we call our value that's going to produce this dictionary for us here. And then we just treat that dictionary, what we're getting back, as an object, and then say, okay, well, now give us the key sample 1 from that dictionary as well. So I can run this. And so what you can see is here, we're going to, in the roseburia dictionary that we have, we're looking for sample 1, and then we can pull out the value 1.6. And so there's a number of built-in functions that work very interestingly and are very useful as part of the dictionary interactions in Python. So here we're going to work with a value that's called in and not in. And so these are defined terms within Python. So if you're leaving these apart. You shouldn't use these as variables. You'd get errors with this, right? If you write the word in as part of your code and put 2 spaces around it, it's going to be asking, Python's going to think you're going to be asking for if this is in something else, right? But this works really well. It's nice. It's straightforward English. It's asking, and what we're doing is sample 1 in dictionary 1? And so here it's just looking into dictionary and seeing as if this string is present there. We can do the same thing with not in. So in this case, I'm asking about sample 1, which we know is in dict 1, or we can ask true or false, is it there? And then lastly, we can ask, is sample 5, which is not something that we have in our dictionary 1, is it present there? And so when we print this, what we get back are Boolean values related to if it's true or not. So is sample 1 in dictionary 1? That's true. Is it not in dictionary 1? That's false. And then is sample 5 present here? That's also false. And so similar to lists, we can use the length function to return the number of keys in a dictionary. And so we have a couple dictionaries here that we can work with. The first one is our dictionary 1 here, which is sample 1, sample 2, sample 3, sample 4. So the length should be 4 keys long. Dictionary 4 has 2 keys in it, right? It contains our Bacillus and Roseburia keys with 2 corresponding values. And then we have our dictionary within the dictionary. So we're calling our particular key here Bacillus, and then asking what's the length of the return dictionary that we're getting back. And so if we print that, it's 4, 2, and 4, because the dictionary within Bacillus contains the same number of keys and values as the dictionary 1. So we can do, there's a number of other functions that we can work with. Some of these are more useful than others. So here's one where we can take dictionary 3 and we can just clear it. And so what's going to happen is we go back to the state where, so dictionary 3 starts off as empty, and then we filled it with content here. And then it's now empty again. So basically what we've been doing by clear is resetting this empty dictionary curly brace setup, right? One of the other things that we can look for is we can, again, get a key. And so this searches a dictionary for a key and returns its value. And then if it's not present, it returns none. So this is different than asking for what happens if you ask for, if you do something like this, if you do print dict1 sample 5, right? So sample 5 doesn't exist there, and we'll get a different output from doing that. So what's going to happen here is that we're going to recover the value from sample 1. And then here, when we ask for the get of sample 5, because it's not in our dictionary, we're going to get returned the special data type none, right? So this is to say that it's not present there. Here, when we ask for it, we're going to get an error because there is no key that matches that. And so get allows us to more accurately ask for something that may or may not be present in our dictionary. And then this last thing is, so get actually has can accept 2 conditions as part of its function. And so instead of returning none, what we can do is we can return some other value. So in this case, we'll return a -1. And so this might be good if we're populating a table or trying to get an output. Instead of none, which is nothing, if we're populating like a CSV file, we can populate something that's easy to either filter out or see going forward that it's actually a non-value. So let's run this, and we're gonna get through our first 2 steps, which is get sample 1, which returns our value that's there. We're going to return get sample 5, which returns a none, and then we're going to get to this line where we're going to ask for sample 5, but sample 5 is not one of our keys, so we get an error called a key error. So we'll comment that out and then rerun this. And then what we've done here is we've changed the output that we're getting back from get from none to -1. The function item returns a list of tuples. So this is the reverse of having a list of tuples and converting it to a dictionary. If we run this, what we end up with is our list of tuples. So these are the same elements that we've had in our dictionary going throughout this example, and now returned as a tuple. So it's just simple, a nice way to get that information out. So this is maybe one of the things that I use. I find myself by default using this lots of times. And so this is the function keys. And so in this format where we take our dictionary and we give it we have this function with no values in it, what happens is we return a list of keys from a dictionary. And so this is actually really convenient because we can do things associated with for loops where we then iteratively step through our keys to do something to the data that's present there, right? Either do a search on it, explore it, make changes to it, or go forward in some way like that. So if I run this, what I get is a dictionary or a list of keys that come back, right? So it's just our keys in our data set. So here is keys partnered, is keys partner values. And so values returns a list of the values for each key, but not the keys themselves. And so this has its utilities for other things. It's not maybe as used as often because your list of values can't then be used to search the dictionary, right? Because you can only search a dictionary based off of the key values there. But what's going to happen here is, so here we're going to return our values from our dictionary 1, which will be associated with these keys. I've created a new dictionary, dictionary 5, which then has a key value pairing of 1 and 10, 2 and 10, and 3 and 10. And so what's going to happen here is we'll produce a list of our values, and they'll all be the value 10 because those are the values that are set in this dictionary. And then lastly, or not lastly, we have 3 more items that we're going to talk about. One is pop. So there's a very similar function for this in lists. Pop removes the key value. It removes a key value pair from a dictionary and then returns the value. So in this instance, in our dictionary 5, where we had 1 and 10, when I do pop, it returns our value, the value associated with it, 10. But now if and I'm going to add a cell here, but now if I do print dic5, which had 3 keys in it and 3 values, if I run that, you'll see that pop actually removed both the key value pair from the dictionary. And so we can do this for lots of elements, right? So this is our dictionary 4. This had Bacillus and Roseburia in it. If I run pop here, it removes Roseburia from the dictionary and then gives me back the dictionary that's there as the returned value. So in dictionary 4, we had Bacillus and Roseburia. Faecalibacterium isn't present there. And so when I do pop, I'm going to get a key error because there's no value, there's no key there that matches that. But similar to get, we can actually provide it with a alternative response. So instead of getting a key error from this, we can get returned a -1. And that has a lot of useful things that we'll talk about in the coming weeks. And so if I run this, it's going to say there isn't a key, but instead of returning an error, I'm going to give them back a -1. So the next function is popitem. And so popitem is similar to pop, where if pop removes the key value that you've given it, popitem just removes the last key value pair from your dictionary. So this can be a little tricky. It really only works when you know what your input order was to your dictionary, right? So it kind of has a fairly limited amount of elements for what it can be used for. But in this instance, I can do dic2 popitem, and it will give me the last item of this dic2 dictionary, which happens to be nitrogen 2 and 1.4, and it gives it back to me as a tuple. So there's some usefulness in it in terms of the fact that you're getting the tuple back, but not necessarily always maybe the most directly useful function for working with dictionaries. And then lastly is the function update. And update allows us to merge dictionaries or key value pairs into an existing dictionary. So here I'm going to create 2 new dictionaries. Dictionary 6, which has A, B, and C as its key values with a corresponding 10, 9, and 3. And dictionary 7, which has D and E as their key values with the corresponding 11 and 5. And so what we can do is we can do 6 update dic7, And what we're going to do is we're going to take all the contents from Dic 7 and we're going to add it to our Dic 6. And so here we go from having 3 key value pairs to 5 key value pairs. And so we can do this in a lot of different ways. We can add in, so here we're going to add in 10 and or D11 and E5 into our dictionary using update, where we're giving it as a list of tuples, right? So this is again, similar to what we've seen before. We can take a list of tuples and convert them into a dictionary. We're using the same values here, so they're just going to replace the ones that are here. So if we run it, we'll end up with the same dictionary. If we were to add another tuple here, which we can call F, and I'll just put a 7 here. And now when I run this, again, it'll replace D11 with D11 and E5 with E5. But now when we run it, we'll also add in another key value pair of F7. And then lastly, we can also do this, again, this will just erase this, is we can use this formatting where we give it we give it a list of arguments that we're hoping to include. So here we're going to say D, which then we're going to set to equal to 11, and E, which is set equal to 5. And so we can also do G equal to 3 and generate that. And then we've added, and so this list can go on for as long as we need it to. And then we've now added, using update, another key value pair as part of our dictionary. And so with that, we'll conclude our lesson 3 tutorial looking at lists and dictionaries. Thanks for joining, and we'll see you back here for future lessons.